Welcome my dear student, how are you? Today we shall learn about the LENZ'S law. Previous day we shall learn about the Faraday's law and electromagnetic induction. But today we explain different phenomena with LENZ'S law. I know you know the law, LENZ'S law, and you also read it in many books. But today we shall clear the topics and it's briefly discuss energy conservations by Lenz law and what is the Lenz law. So please keep watching. So basically what is Lenz law gives? In the starting of this video I can ask you a question, that is, three conducting circular coils are placed parallel to each other. These three conducting coils A, B and C are placed parallel to each other. If a current parallelly, this is the same axis, if a current flows through the middle of the coil, that is in coil B, so what is the option? What option is correct? A, B and C repels, A and B attract, or A and B repels where B and C attract, or A, B and C repels each other. If I put or ask you this type of questions, it can be answered by Lenz's law. In joint entrance examination or many other examination, such type of questions will be questioned. First a question will be asked and you have to solve the answer in few seconds. So if we have a brief idea about what is Lenz law, then we can easily answer this question, otherwise we do not understand the basic questions. So please keep watching for this type of video. So we go with Lenz law. Please watch my video till last end, then I can able to answer the question. Lenz law is basically gives the direction of induced EMF is basically gives the direction of induced EMF. Is basically gives the direction of induced EMF. Lenz stated that when there is a change in magnetic flux through any closed loop, then a current is induced in that loop due to relation between the magnet and the coil. A current is induced in this loop, and as a result, when the magnet is moved closer to the coil, there is increase in flux through the coil. But here an EMF is induced, as a result also a current is set up in the coil. But the direction of current is such that it will produce another magnetic flux which opposes the magnetic flux due to the original magnet moving. So when current is induced in the coil, the induced current will produce a magnetic flux which opposes the original magnetic flux. So the direction of current is in such a way that the flux will always oppose the original flux. If the flux is increasing, then the current is set up in the coil in such a manner that the flux produced by the current opposes the original flux to decrease it, or if the original flux is decreasing through the coil, if the magnet is moved away from the coil, then flux is obviously decreasing because the number of lines passing through the coil is very small then. So in that case, the current will be set up in opposite direction to increase the decreased flux, This will the Lenz law. So if we statement, that is the direction of induced current is such that it will oppose the cause which produce it, that is, it opposes the change in magnetic flux. This is the statement of Lenz law. The direction of induced current is such that it will oppose the cause which produces it. Which cause produces the induced current? Change of magnetic flux. If there is a change in magnetic flux, then only an EMF as well as current will be induced. Otherwise, no current will be induced in the circuit or coil. So the direction of induced current is such that it will oppose the cause which produces it, that is change of flux. That is, it opposes the change in magnetic flux. So this is the statement of Lenz's law. इसको अपनी कॉपी में लिख लो और किसी भी बुक में आप इसको, किसी भी बुक में ये मिल जाएगा, उससे भी आप इसको अपने कॉपी में लिख सकते हो. सो as we say that, देखिए अगर एक मैग्नेट, ये बार मैग्नेट, we can consider here two case, number 1 case, number 2 case. अच्छी तरह से समझना, क्योंकि अंडरस्टैंडिंग जो है उसको, जो कॉन्सेप्ट है वो क्लियर करना बहुत ही ज़्यादा आवश्यक है किसी भी एग्जाम में रैंक करने के लिए, अच्छी रिजल्ट करने के लिए. नंबर 1 पिक्चर, the magnet is moving towards the coil with a velocity v, and in number 2 picture the magnet is moving with same velocity away from the coil. अब अगर ये मैग्नेट इस कॉइल का पास आ जाता है तो इसमें नंबर ऑफ मैग्नेटिक लाइंस विल बी ग्रेटर, so it increases the original flux, but Lenz said that it increases the flux, so and current is set up in the coil, but in what direction? This gives the Lenz. Henrik Lenz gives the direction of current. Now if the magnetic field of lines increases the flux, this flux is original flux, then a current is induced in the circuit in such a manner or such a direction that it will oppose the change in flux. How it possible? A current flows in such a direction that it will produce another magnetic flux of its own, which opposes the original magnetic flux. As a result, flux will decrease. As a result, the total flux will decrease. So when the magnet is moved towards the coil, as a result flux will increase, but the current flows in such a direction that it produces another magnetic flux which opposite the original flux. Again, when the magnet is moving away from the coil, then the number of field lines will be less, that it will decreases the flux, but here also the current produced in such a manner, that it produces another magnetic flux which direction is same as the original magnetic flux. So it will increases the magnetic flux. So when the original flux increase, current produced and flux is also produced which opposes the original flux, and also when the original flux decrease, current produced in such direction that it will increases the original magnetic flux. Just opposite, if flux increase, then current produced to decrease the flux, if flux decrease, current produced to increase the flux. This is the basically Lenz law. Now what is the mathematical expression of Lenz law? What is the mathematical expression of Lenz law? Now from Faraday's law we can get the magnitude of EMF E is equal to d phi dt, rate of change of magnetic flux. From Lenz law we get the direction, that is minus d phi dt. Minus indicate, negative sign indicates that EMF opposes change of flux. E equal to minus d phi dt is the mathematical formula of Lenz law. If instead of a single coil there are n number of coils tightly wounded, therefore for n number of turns E is equal to minus N d phi dt. This is the mathematical forms of Lenz law, E equal to minus N d phi dt. Now, I hope you understand this. So, we go with energy conservations of Lenz law. Here phi is in Weber, T is second, E is in EMF, that is volt. So, we can go with some energy conservations of Lenz law. तो क्या सीखा हमने, जो होगा ओरिजिनली होना चाहेगा उसको जो करंट है वो अपोज करना चाहेगा. अगर फ्लक्स इंक्रीज हो रहा है तो करंट ऐसा डायरेक्शन में फ्लो होगा उसको डिक्रीज करना चाहेगा, और अगर फ्लक्स डिक्रीज हो रहा है तो करंट ऐसा डायरेक्शन में फ्लो होगा कि वो डिक्रीज फ्लक्स को इंक्रीज करना चाहेगा. नाउ वी कैन गेट एनर्जी कंजर्वेशन. Suppose a bar magnet is moving with velocity v to a circular coil A. Now what will occur? If this is moved to the coil, flux will increase, but current I produced in anti-clockwise direction, so that the side of the circular loop facing towards the magnet gives polarity N and the opposite sides gives polarity S. As a result, this N will repel the north pole of the magnet, so that the flux will be decreased. That is, it opposes the motion of the magnet, so that it opposes the motion of the magnet or change of flux. Because if the magnet is moving towards the coil, flux will be increased through the coil. So, current is set up in which direction, that it will opposes the motion of the magnet to decrease the change of flux, to decrease the change of flux or decrease the number of field lines. Again, if the reverse phenomena will occur, if the here galvanometer G, if the magnet is moving away from the coil A, then the flux will be decreases. But again here the current is set up in such direction that a south pole created towards the magnet and a north pole created opposite to the magnet N pole. So it will attract the north pole to, that is, it opposes again the motion of the magnet or change of flux. Because due to moving of the magnet, the change of flux will decrease, so current flows in such direction that the flux will be added up to increase the net flux. Here flux will be subtracted to decrease the net flux. This is nothing but the Lenz law. Now, energy conservation means that the total energy will be conserved. That is, some energy will be converted into any other energy. For a while, we can say that here S pole is created and here N pole is created. That is, if Lenz law will not occur. Let us assume that the S pole created here and N pole created. N pole is already in the facing S pole. Then what happened? Then it attracts the north pole, which increase the speed or velocity of magnet. We know that opposite pole attract each other. Therefore, if velocity increase, then it increased kinetic energy also, half mv square we know. So, if kinetic energy increase, then it will be violation of energy conservation, because here no any external source is present to convert the kinetic energy into electric energy. That is, without any work done or external source, without any work done, the kinetic energy is converted into electrical energy. That is, more the kinetic energy, more will be the electric energy. But this is the violation of energy conservation. So, the Lenz law is held for energy conservation. So, this will be not occurred, because here without any work done, energy cannot be converted into other form. To convert or to gain energy, we have to do work done. So, actually what happened, that N pole is created here and S polarity is created in the opposite sides of north pole of magnet. As a result, these two poles repel each other. So, to overcome the force of repulsion, we have to move the magnet to the coil and have to work done. We have to work done against force of repulsion. Force of repulsion, which is converted in the force of repulsion, which converted mechanical energy, here is kinetic energy, into electrical current or electrical energy. So, here kinetic energy into converted electrical energy, because work is done against the force of repulsion. Same here, S pole is created and N pole is created. So, we have to move the magnet away from the S pole. That is, here work done against, here work done happen against force of attraction. Which again converted kinetic energy to electrical energy. So, we can say that Lenz law is nothing but obey the principle of energy conservation. I hope you understand the whole process. Now we can answer. Now we go to answer the question. I see in the starting of the video that 3 loop A, B and C are placed parallelly to each other, and if current passes through B, then what will happen? So, if current passes through the coil B, it will increase the flux of B, and also as these two loops are parallel to B, it also increases the flux of A and C. It also increases the flux of A and C. But so it also increases the flux in A and C means that is a current is induced in both A and C. But to decrease the increased flux, these two loops will be moved away from the loop B, because as we move away from the B, the flux will be decreased. It tends to decrease the increased flux. I hope you understand. A current is induced in the B means it is a current is flowing through B, that it will induce current in A and C, that will increase the flux. But Lenz law states that the current is tendency is current to decrease the flux, so it will move away from the B. So the answer is both A and C shows repulsion to A, or A, B and C repulse each other. This type of basic question will be said to be answered in the joint entrance examination or NEET examination. So I hope the concept will be clear. Next day we can go with self-inductance, mutual inductance. If you like my video, please subscribe my channel and press the notification bell. Thank you.